Right. Now, under the first one, I would like to talk about data distribution, especially the first part. Uh, we are going to discuss what data sharding is, and also uh, there are different replication models, right? So under that, we will discuss what database sharding is, and then different alternatives available in data sharding, and uh, and then what are the advantages and disadvantages of using these database sharding, and how this is working. So these are the main concepts that we will discuss under this. Now, let me first ask the question of what do you mean by uh, the database sharding? So the sharding is basically which we normally talk about splitting um, the data that we will have in uh, different chunks or different partitions, especially when you have the database distributed in multiple database, what we call the servers or the nodes, right? And when we look at the idea of the sharding, we will basically we can database, we can handle when you make it several partitions, you can handle more requests than when you have a single machine, right? There are different um, uh, sharding we can talk about in MongoDB. That means when we have a single database, or when we have data in a single machine, when we have large number of the request comes in, instead of handling in a single machine, we can allow it to have horizontally, right? So now we can talk about this in different levels. We can talk about in horizontal partitioning, or we in other terms we can use vertical partitioning or vertical scaling, or we can separate into special databases which uh, increase this, right? Now let's move on. What are the key aspects of um, the data sharding in NoSQL design? Now, few things we need to discuss when it comes to uh, data sharding. The first one is we will to talk about the scalability. Now, scalability means how you are going to add servers, and how you add more servers in case that you are going to have a cluster of servers when your data grows. Now, by adding more servers, we provide basically increased storage, and you also provide more processing power. So when you say scalability, and by distributing the data across multiple shards, we call it. So the system can handle large data sets as well as large query loads. So that's one of the key aspects of data sharding, that is scalability. That means improving the accessibility of your data by adding more servers or more machines so into your clusters of servers. Second one is the performance. Now, performance is especially now when you have like more shards, more partitions, we can improve the reading and writing performance because you can parallelly read and write. You can parallelize the data operations across several servers, so they can process queries independently. So which means you will have faster response time, especially when you retrieve or performing any modification. Right. The third point is what we call shard key selection. I'll come to that point in detail. The point here is like how you are going to, separate out or shard, or how do you efficiently, make this data into pieces. So choosing appropriate shard key is very, very important. We say it's crucial for efficient sharding. And this key we should use to across all the shards, and then make sure that it is not overload any of the nodes, right? So when you're making the what we call the shard key, we want to equally distribute the load. So depend on how we select. So this is very, very important when you're selecting a shard key. Then next one is data consistency. So now when you're splitting your data or when you're creating shard, it will create a data consistency problem. Now, here we talk about data is distributed. Now the data is distributed among multiple the nodes. The maintaining the consistency will be a problem. So we need to use like different strategies how you are going to consistency handling sharding. For example, we are going to talk about the CAP theorem later today, that what we need to prioritize. So for example, we are going to discuss prioritize availability and partition tolerance. We normally say AP. Over strong consistency, we have CP. So which will allow what we call eventual consistency, while others provide for strong consistency across the shards. Then the next one is shard, what we call rebalancing and maintenance. So you know that now this is, we are scaling up when we need like getting more requests. We are going to keep on adding nodes and data will be, shard. So you have to rebalance your data, right? So the idea is when you are distributing data, when you have splits, so splitting data across these different nodes is a crucial point. So we will talk about something called how to optimally distribute data. So rebalancing means we need to move data. We have to move data from one shard to another, make sure that you have optimal data distribution. So when you're moving data, which is very resource intensive, operation. So we need to properly plan and we have to monitor. So we want to avoid any, issues, the problems, the disruptions to the existing, the system when you're working on uh, the cluster of computers. Next, we need to discuss about failure handling. When we talk about the failure handling, we focus on what we call the fault tolerance. So when you talk about shard, or that means a split of data, or a node, if it is fails, now this failure we want to handle without affecting the other one. One is we should not lose data, or we should not, make an issue of availability of data. So the point that we are going to make here is we are going to make replication and data redundancy by replicating the data and replication and using data redundant technique. We want to make sure that the data is available when in an event of failure. The last one is called query coordination. So when you talk about the query coordination, we are going to talk about coordinating different shards, and when you process a query which span multiple shards. So now remember, data might not be in a single place. When there's a query comes, we want to distribute, which means there should be a coordinator who is responsible for routing these query, right? Because you have to, query coordination is very important to, maintain the performance. So these are like, as you can see, some of these, right? The points, especially when you're talking about shards and their key aspects. Right, now next look at shard architecture. So the next one. Now, as we have already discussed this, the shard is what we call replication, or sometimes we say it's a replica set. Simply you have a subset of data, right? And then we have mongoose, we have will be the query router, and for the applications, and it will handle both simply read and write operations. And then what we have, config servers, we have some metadata about the data shards, and simply this will configure servers. We will have state and organization of shard data, right? And this is simply a single shard. You can see here we have it look like this. and it's shows you information on this. Now, what are the benefits now we are getting? We already discussed the ideas. One benefit is you can improve the read and write. So when you talk about the router, in this case, MongoOS can distribute the load into different shards, right? Now, for example, let's say we have a situation. Let's say it can process 1,000 operations per second, right? So, so one shard you can say it can operate on one thing is parallelizing this. So you can say here we have 2 shards. So one you can work on 1,000 operations per second. So by distributing the different shards, we can improve the what we call the throughput, right? So that is one of the ideas. Then the second one is again, like when you talk about you can see the capacity. So in this particular case, for example, you can see the capacity increase. So let's say we have one shard, we have 4 terabytes of data. So that means by having multiple shards, so then you can have data, improve the capacity. Right, that is another idea that when you talk about the shards. And another benefit would be like, for example, now data you can keep in, localize. Now localize mean, let's say we have some financial data where some data related to some countries, you can keep in geographically in specific areas. Now, for example, we can have several shards, and then we can look for North America, for example, that particularly that data we can separate out. Remember that this whether we are going to separate data based on the region and not, it's a key design that we have to decide on when we are creating the data shard. Right. Okay. So let's now look at the data distribution idea. Now that we have discussed about like how data sharding works, as well as the importance of data distribution and the benefits that we are getting. The first thing is we need to discuss how you can actually create these shards or the database chunks. Now, when we talk about database chunks, the first one is what level we are going to, separate them, right? So we know that in MongoDB, what we have is data collections. So that means when we create, shards or you can splits, that happens in what we call the collection level. We talk about the collection, isn't it? So we talk about the collections, and then the data distributions happen in collection levels, right? We have to split the data, and then we have to use what we call the shard key, and we have to make sure that they are not overlapping. So depend on what value we are going to have, right? So simply let me show you a graphic which represent this idea. So for example, let's say we have the chunks that we want to create based on some key attribute. So let's say we have a key which separate out the chunks, and then we can decide the key values, and then for the ranges, right? So we need to split based on the ranges. And one thing is how we are going to do this, right? So now when you say shard keys, these are based on the fields within the document, and it depends on which shard the document reside and what ranges and the amounts, right? And this information we have to keep in the configuration. So this shard key that we are going to decide on here, it will impact our cluster performance, and we have to choose carefully, right? So you can always change your shard key, and you have to decide on which shard key is best for you, right? And then balancer, there's a background process which balance automatically the chunks across the shards, right? Same number of chunks. Right. The next thing is we are going to decide which strategy we are going to use. So the next one that we want to discuss is what sharding strategy is. So under that, we are going to talk about two ideas. The first one is some range sharding, and also we can talk about what you called hash sharding. So so let's start with the first one, which is what we have seen here is called range. We will define range based on shard key values. So that's exactly what we have right now. So let's say if it is X, so based on the value of X, we are going to make the ranges, right? So that is the what we have in the shard key strategy, right? So this is called range sharding. And range shard, so those key values are close, you should be in the same chunk, right? And so that is easy. The second one that we are going to discuss is called hash. So hash sharding means we have to compute some hash function where we want to find out what the key value is. So this is called hash sharding. So in hash sharding, we will have a hash function, and then depend on the hash function, we are going to create the chunks. So hash function which we'll use for that to decide on the chunk, right? So implementation that we have to do, sharding, which we will discuss. We have to decide on what we call the replica set, and then we have to configure server. So that part we will have a separate discussion on how to create the collection, and then also like how what field we are going to use, And so that part we can discuss. Right now, now when you are looking in detail, like, so how you are going to consider things. For example, let's say whether we are going to create on horizontal or vertical, and so on. So that we need to discuss, right? So the architectures, two architectures we just talk about is the first one we call range sharding, which we have this, and then ranges we can define. Now, for example, let's say you have IDs from, let's say, 0 to 50. So that means we have to define a range under the range sharding, and then we have to define what the shard ID is. So for example, let me take example, and then we can talk about the ranges and the shards, right? So let's say we have range ABC. So in this particular case, 0 to 20, and then 20 to 40, 40 to 50. So simply we will define those ranges with the shard IDs, let's say ABC, right? So the range is the what we are going to have the shard ID, or we are going to have shard key, right? So for example, let's say how you are going to handle a query, right? Now let's say we have a query which requests IDs 10 to 30. Now can you tell me what shards we need to query? Yes, let's say we have a query now. Now we have separate out the data. The ID range between 0 to 20 is 1, 20 to 40 another one, and 40 to 50 is another one. So there's the question, and there's a query comes in which requests the shard or query. Okay, let's we have a query for all records with this ID ranges from 10 to 30. Now what happens? How many shards that we have to discuss, query? We have 2 shards, right? Isn't it? So when you say 10 to 30, we have to query both A and B. So when you have a query A and B, right? So you now see that this key or else the ranges is very, very important, right? The frequencies is very, very important.
Yes, sir. When we have the range 0 to 20, it's, I think 21 to 40 normally we start.
Exactly, yes. Yes. So when you say, you can see the bracket and the rounded bracket here implement that there's no overlapping. Yes, true. The question is like when you put up a query on the shards, now when you have a situation like 10 to 30, so you have to query both shards A and B. And now you can see your decision of making the range based on what queries you might come, right? So every time if you are getting frequently, if you are getting something like this which come up with all in the charts, might be a problem because you have to query both A and B. Right. Now, this is very easy to understand, but the problem is the availability of the suitable, the shard key, as you can see, and also selection of what we call the appropriate ranges. Right. So that's about the what we call ranged, or sometimes we call dynamic sharding. So that's range sharding basically. Right. Now, the next one, now, for example, what we call the second one we call hash sharding. So, for example, in this particular case, we can talk about a record, and we have to have some kind of a hash function or algorithm to identify some hash value, right? So now the function for hash value could be very simple. So let's say you can say simply you can get the mod of number of shards. Right? So for example, let's say we have a hash value. We can say hash value. We can get the ID, and then we can simply divide, or we can say the remainder of number of shards. Right? So for example, simple hash value could be we get the remainder, we get whatever the ID, let's say similar to this, but we will get number of shard. If it is 3, let's say you divide by 3, the remainder will give you the shard. And you see that this is very similar to what we have done in previous case. So it's very similar to what we do in the range-based sharding. That means this is determined what is the allocation of the record given a shard. And in this case, when you use the hashing, it allows more even distribution. Right. Now, the problem is, like, let's look at some of the issues. Now, first thing, the query operations. Again, like in previous case, when there's a query operation, it might distribute at multiple shards. So the problem here is, now in previous one, we have a meaningful ranges. Like if you take the first one, and let's say when we say, okay, we want to retrieve records from 10 to 30, it's meaningful because we have base range base. But when you have a hash base, we are not really, we disregard the meanings of the data. And the second one is pre-sharding. I told you, like, sometimes we have to move data in between. This could be very expensive, right? This could be very expensive. So make a note of that, especially when you use hash based sharding. Right, now I would like to discuss another idea, especially what we will call entity or relationship based sharding, or especially when you have the data coming from normalized relations. Right, now let's move on to that one. Okay, now the apart from the first two, the third one is very interesting, especially if you have data with a schema. Now, normally, when you talk about the NoSQL databases, we don't talk about a schema. But we know that sometimes we have to have a schema in databases, especially let's say you have data coming from a relational database like MySQL. So naturally, when you have a data set like this, now splitting data can be done based on these entities, or you can say based on different relations, or based on separate tables. So what you can do is you can spread the data to several tables. So let's take an example. Let's say we have a shopping database, right? And let's say we have users and payment methods, right? And you know that sometimes users have a preference of payment. Some prefer to pay in cash. Some prefer to pay in, let's say, credit card. So that is tied to the user. So how do you like the separate them? So that means we can keep this related data together. So the problem is, otherwise, again, like in early, when you're querying, so there's a increased burden of getting data from different charts, right? Okay, so that's the other type of sharding. Then the next one is the geography-based sharding. Now, earlier, remember I showed you like in an example where we have the data in related regions in the same place. So this is again very interesting idea. And this is what we call the geography-based sharding or geosharding, is the idea to keep what we call the related data in a single shard. And we can keep in where the data is close to what we call the local information. Right. So these are the basic ideas that I would like to discuss about how we could, talk about, data sharding, right? And especially this is important when it comes to replicate, especially the part of the data. We need to make a decision on how we should be sharding, right? Or making partitions, because that affects, for example, especially based on the queries that you make and how it, affects to the queries, right? So we look at how we do it. Right. For the implementation levels, we can talk about this. We need to configure, especially the servers. And then first we need to set up what we call the config server. And we have to decide on replication. So we have to decide on what MongoDB processors. That part, I think, yeah, we'll talk about separately how we can do that. So once you do the configuration server, we need to set up what we call the shards. Again, we need to decide using different options, right? And then finally, we have to turn on shard in the database. And then we have to decide how we are going to make the collection and how do you separate the shards. Especially you can do this using hash sharding or range-based sharding. So the steps are very small, but yeah, let's have a separate session on practically how we could do that part, right? Okay, so in theoretical wise, that's what I would like to discuss about the data distribution part, and also the characteristics, as well as issues that you might have to face. Now, my discussion, I focus on MongoDB, but depend on different types of NoSQL databases. We can talk about different implementation as well. So it depends on what kind of databases that you are going to use. Okay, now I would like to briefly talk about how these the CAP theorem, right, which affects this, and under that I want to discuss like when you are going to have compare, especially when you talk about um, the different implementations, what we can actually focus on, right? Move to the our next topic. So under the next topic, I want to discuss about what we call the CAP theorem. Now, in CAP theorem, usually we talk about, especially in distributed systems, where we will talk about in these different databases, where we keep replication of the data, like the sharding that the discuss, we have ideas. The replication, we are going to keep performance over when we have multiple servers. The advantage what we discussed was it will improve the availability, especially when there's a failure, since we have a replicated data, that the data is readily available, especially disaster recovery is one of the aspects, right? Now, depending on what kind of a data you use, if you have done it this replication incorrectly, you might lose your data or may lead for the corruption as well, right? So we need to understand what replication and why we need it. So under database systems, usually we talk about what we call the CAP theorem. So what says, it says it is impossible for a distribution system to simultaneously provide more than 2 out of what we call consistency, availability, and partition tolerance. Right now, when we talk about the consistency here, now we talk about all the nodes, all the clients, same data at the same time, right? And when we talk about the availability, and then when we have even if there are a failure, the system continues to operate. And partition tolerance, even sometimes there's a failure of different nodes, right? The system continues to operate. So different systems may provide you, different items. I told you, like the CAP theorem says that it provide only 2 out of the 3 what we have. So as you can see, right now we are focusing on MongoDB, and then where we focus on what we call CP. That means consistency and partition tolerance, right? The others, when we say CA, for example, consistency and availability, and AP, for example, availability and partition tolerance. And you can see the black in the middle, which says that all the three is difficult. Now, what we do in MongoDB, what we have is we have master slave kind of replication. So we design one as a server, and then others like slaves, right? And then we are going to keep track of all the changes, and then based on that we are going to make the decision. Right. So overall, what we want to use is the replication strategy. Simply, we want to have application. Application should simply read and write operations with the primary server, and then we have to replicate in all the secondary servers. So that's where we talk about the data sharding is. So theoretically, this is what I want to discuss under the first part of today's session. The second part that I would like to discuss under the same topic is how we can handle transaction and processing with NoSQL systems, because you have already done transaction and processing with NoSQL, in traditional relational database management system. Now, when we talk about transaction processing, the main thing that we want to discuss is when we have group of related items, how we are going to handle, right? So according to this, now let's say in some application, we might actually change multiple data at the same time. So when you have a situation like this, how you're going to handle the situation. So that's what we want to discuss under transaction processing management. And especially this is supported in relational databases. We discuss, if you remember, commit and rollback operations. And especially when you talk about the transaction processing, we talk about read and write operations, and also like parallelizing this so that it won't affect the final outcome of this. So when you talk about this, we talk about what we call ACID model. So when you talk about the ACID model, right, we talk about four things. So in ACID model, we talk about atomicity, which is we want to talk about the when we execute a particular what we call a transaction. So when you talk a transaction, we talk about it as atomic level, which means either we will complete, or if it is fails, you have to go back to originally where you were stands, right? So that's what we call the atomicity in ACID models. Then the second one, we have to talk about the consistency. Again, when we talk about the ACID model, the consistency plays an important role. That means it should go from one valid state to another valid state. So that is what we will normally use consistently. The third one, we have isolation. When we say isolation, we will talk about concurrent transaction. That means we know sometimes transactions run in parallel. And each transaction goes from one state to the other state. So when you see isolation, although they are concurrent, right, their effects are, or their isolation prevents any interference between these transactions. So that's what we want to talk about in the isolation. And then the last one, what we have is called what we call the durability. Now, when you talk about the durability, we talk about the committing it. So when you say commit, right, that's it's final. So in what we call the committed data, that means there's no change of when you say durable. Now, when it comes to NoSQL databases, so in traditional relational database systems commonly associate with this ACID model. So in NoSQL system, what we have is what we call Bayes model. And it's different from what we call the ACID model. So in NoSQL system, so we need to talk about what we call Bayes model, right? So three things we need to discuss. Basically available, that is to say that it will guarantee what we call the basic availability. So that means when there's a failure, or there could be a partition, so availability is prioritized. So that is what we call basically available. And then the idea is it allows systems to provide what we call the continuous service, even temporary with some inconsistencies. The second one we talk about soft state. So that means NoSQL systems allow flexible or evolving schemas. That means, it's not like in relational databases, it's not fixed. So that means the structure of the data can be changed. So you don't have to confirm the new schema. So soft state means it's easier for the scalability and adaptability. So that is the second one. Third one, eventually consistent, which means not immediately consistent. NoSQL system, we aim for what we call eventual consistency. So it means that after a certain period of time, the system, we need to converge to consistent state, right? Across all the partitions, the replicas, shards that we will have. So it means it allows what we call the asynchronous replication and data synchronization, which result increase availability and scalability. Right. So different mechanism and different techniques are eventual. So we will use conflict resolution, versioning. Then we will use distributed consistent protocols like CRDT, which call conflict-free replicated data types. So this model for suitable where we need high availability, scalability, and partition tolerance, more critical than the consistency requirement, right? And not all strictly adhere the base model. So for example, how MongoDB adhere right base, we can talk about what we call in MongoDB, especially when you talk about with the base model, what we call eventual consistency. So when you look at basically available in MongoDB, so how MongoDB ensures the basic availability, it allows read and write operations to continue even in network partitions or replica set failures. So which means client can access the database, perform operation, even if some nodes are unavailable. So that's how the MongoDB handles the basically availability. The second one in MongoDB, when it comes to soft state, and we know that in MongoDB, we don't have an schema. We can say MongoDB, what we have is schema-less, what we call document model, right? So that means it allows dynamic and change of data structure. So we have collections. Collection can have different structures. So that is not rigid. So it allows for soft state. Then third one, when it comes to eventual consistency. So to eventual consistency, we will have replicas. That means multiple MongoDB nodes, we are going to have copies of the same data. And I told you like they are using primary and secondary. So when you perform write operation, usually it happens the write operations on the primary node, and then it asynchronously propagate the secondary nodes. So that's what happens. So there will be a delay, but it propagate to all the nodes. So therefore, eventually, the data will be the consistent, right? Okay, so I think those are the things that I will have for today. But I want to have a separate session on practically implementing this. First of all, creation of multiple replicas. Maybe I think we can, I will prepare that for the next week. with the help of, maybe we have to use the Atlas implementation with MongoDB. And then we also need to discuss about the data sharding, separating for a example. For example, one thing I'm aiming at is the databases or the problems that you have worked on, how you are going to make a decision on how to, shard. That means how to split your the data. So that part I want to concern. So MongoDB actually provides several configurations. For example, um, things like how to read the data. So, and from which nodes you can retrieve the data. And then same goes with the writing as well. So for example, when you want to write the data in MongoDB, we can decide whether you are going to wait for others for the acknowledgement. And then there are some monitoring mechanisms. So it's also available in MongoDB for monitoring the replication lag. So those are like some of the operations available for you to work in MongoDB, especially as a NoSQL system. Right. So with that, once we have that part, I think with that, we can conclude the MongoDB part, especially I want to talk about the implementation of these two. So give me this week for preparing that.